We're now going to look at slope in some different ways, and we're going to look at slope first as a rate of change. Now, all this means is we're going to take and look how is our rise changing in relationship to our run. And we're going to look at this through some simple little examples here, and we'll just make up some situations. So in the first example, I'm going to say, if I was to draw a graph and say, this is the hours you spend studying, and this is the percentage you get on the test, we should know that with 0 hours of studying, you're still going to probably score something on that test. But as the hours go on, your mark should go up and up and up. But it probably does reach a point where eventually your mark would just stay the same, that the hours of studying aren't going to make that much difference to your mark because your knowledge is just your base knowledge. So if I was to take a look at this slope as rise over run, or a rate of change, right here, we could see that if we were looking at rise over run, our rise is going up while our run goes forward. This is a positive, it's going up, and this is a positive. This is a positive rate of change. The more time we spend studying at the beginning, the higher our mark should go. But then we did say after a certain point, we'd look at this part here and say, well, something else is happening here. If I was to look at rise and run here, we have absolutely no change in our rise, like nothing's happening, but the time keeps going on. This is saying that we have a rate of change that is 0. That there is no rate of change. The more I study, nothing's happening to my mark. So that's a simple little example. And I could look at some other types here and say, here's the height of something, we'll say in meters, and here's the time in seconds. So let's say that you're standing on a roof and you're throwing a paper airplane down. So you throw a paper airplane that starts up on the roof, and eventually this thing comes down. And if I examine what's going on in this situation, we can see we have one trend in the data, that this data is just doing this. We could say, well, let's examine the slope as a rate of change. Our rise, well, our rise is actually going down. That means we have something negative happening. But our time is going up. So it's moving along. That's a positive. So this is actually a negative rate of change, which means as the time moves forward, our rise is actually going down. This paper airplane just keeps coming down until eventually hits the ground. This is a negative rate of change. And we're going to be able to just discuss these when we look at graphs. You should be able to say, well, this is a positive rate of change. This is a negative one. And so before we go any further, I'm just going to show you some different types of slopes that we can have. So types of slopes, or we could refer to this as some types of rates of change. And there's only 4 things that we can actually consider here. And we talked about some of them. We can have a positive situation. And what that looks like if we're talking about a line, is the line is going up to the right. So when we look at graphs and we look at lines, we always read them from left to right, just like we read numbers. So positive rate of change means it's going up to the right. Conversely, a negative rate of change or a negative slope means it's going down to the right. And then there's 2 more that we talk about. The 0 rate of change, which we'll see, and we looked at in that studying example, is just a horizontal line. So something like this. It just stays flat. There is no change happening whatsoever. And then the last rate of change, or the last type of slope that we can talk about, we call it an undefined slope. And this is when we're looking at vertical lines, that we're saying there's definitely a rise in this situation, but there's absolutely no run. This is called an undefined slope. So those are the 4 types of slopes that we need to know as we move through in slopes. And we're going to be able to examine these now as we start to look at slope when we're given points on a graph. So we're now going to have to say, how can we find the slope of a line or a line segment if we have points given to us on a graph? So we should all remember this, that slope, which could be symbolized or shorthanded by the variable m, is rise over run. And if we examine a graph, we've got 2 axes. We've got a y-axis, which is going up and down, so this is my rise. And I got an x-axis, which goes left to right. This is my run. So basically what we're saying when we look at slope is that we're saying, if I could figure out how my y's change and divide it by how my x's change, remembering that in science, this is delta, which means change. So the change in my y coordinate divided by the change in my x coordinates, we should be able to find the slope of a line given any points on the line. So we're going to come up with a new formula now that we're going to be using, that slope is actually taking our y's, y1, subtracting it from y2, dividing it by our x's. This is a slope formula that we will be using, given any points, knowing that when we have points, each point has an x coordinate and a y coordinate. So if I have 2 points, here's x1, y1, here's x2, y2. Now right now you might be saying, wow, this is starting to get a little bit complicated. We're going to look at some examples. You're going to see if you could just set these questions up right, you have absolutely no problem in solving them. So remembering that, we're going to move forward. We're going to say, here's an example. We're going to say, what's the slope between these 2 points? We're going to have a point that's 3 over 10 up and a point that's 18 over 40 up. So I chose some large numbers, but we're going to examine how this looks. And we're going to sketch it first. 3 over 10 up, we could say, okay, here's a 310, just estimating. And then 18 over and 40 up, something like this. 18 over 40 up, here's the line segment. If I examine it right now, so I'll just put the points here. Here was 3 over, 10 up. Here's 18 over, 40 up. And if we had graph paper, we can be more precise. But we're just sketching. Right now, by looking at this and by remembering what we talked about back here, we should be able to determine that this is actually a positive slope. It's going up to the right. So my answer better be positive. What I would recommend to do in these situations is to take the 2 points that they give you and stack them up on one another. So say I have 3, 10, and I have 18, 40. Here's my 2 points. Now remember, each point has an x and each point has a y. So we can see that these are actually my y's and these are my x's. So when I go to look at that new formula we just saw, that slope is subtracting the y's and then subtracting the x's, the way I have them when I stack them makes life really easy. Because if you can remember right now that here's my y's, and it says, let's subtract these. 10 minus 40. And now here's my x's. 3 minus 18. Now if I calculate these, we can see in 10 minus 40, that's negative 30. 3 minus 18, that's negative 15. But negative 30 divided by negative 15, two negatives will come out to be a positive. This is a slope of 2. So my answer could be a slope of 2. You could also express it as this rises 2 units for every 1 unit that it goes over. We could see we do have a positive slope. We do have a positive rate of change. So using our formula, we should be able to answer these questions that give us just points. So let's look at another example. And I'm going to say again, find the slope between 8:15 and 10:2. So it's a good idea sometimes to sketch these and say, okay, here's my x, here's my y. If I sketched 8 over, let's say here's 8 and 15 up, here's a point, there's 8:15. And then sketch the other point, which is 10 over, but only 2 up, so something like this. Here's 10:2. Remembering back, this is going down to the right. I should end up with a negative slope when I do these questions, or when I find this calculation. So the first step, I would say, stack our points. 8:15, 10:2. Remembering the first one's x, the second one's y. Then we could talk about that new equation. y1 minus y2 over x1 minus x2. So the slopes, remember, here's my y's. That is 15 minus 2 over, subtract my x's, 8 minus 10. Now the order we do it is super important. So now when we subtract 15 minus 2, that's 13. 8 minus 10 is actually negative 2. So the slope of this line, that is in lowest terms, is negative 13 over 2, which means that this line goes down 13 units for every 2 units it goes over. It has a negative slope. We'll do 2 more examples just to see how we can identify zero slopes and how we identify undefined slopes. So here's another example. And we're doing it the same way. We're just going to say, what's the slope between the point 4,2 and the point 10,2? So again, here's x, here's y. The first point, I go over 4 and up 2. So here's a point. I can say that's 4,2. The other point, I go over 10 and only up 2. So the same thing. Here's 10,2. When I connect them, you could see that this line is staying completely horizontal. So we should end up with a zero slope in this calculation. So let's just look at the points again. I'm going to stack them. 4,2, 10,2. These are my x's, these are my y's. I'll remind myself of that equation. Subtract your y's, that's my rise. Subtract your x's, that's my run. Right here, if I subtract y's, that's 2 minus 2. Then subtract your x's, 4 minus 10. I'm actually getting 0 over negative 6. So that means my slope is actually 0 in this situation. And you could test that on your calculator. 0 divided by negative 6, well, that's 0. So I have a 0 slope. And I should. It's a completely horizontal line. The last example then is going to be to say, how do we identify a vertical line? So again, we'll just say, what's the slope between the point 8,3 and the point 8, negative 4? Now I have some negative coordinates here. So again, I'm going to draw this. This is known as the Cartesian plane. And the first point, I'm going to go over 8. and I'm going to go up 3. So here is 8, 3. And it says the other point is go over 8, but go down 4. So over 8 down 4, here's 8, negative 4. And you could see that this should be a completely vertical line. And we did say vertical lines have a slope that we call undefined. So let's see if we're doing calculations, how could we determine that if we didn't see the graph? So again, I would stack my points, 8, 3, 8, negative 4. The equation is subtract my y's and then divide it by the x's subtracted. Here's my x, here's my y. So for slope, right here I'd say 3, take away a negative 4. And then that's 8 minus 8 for my x's. 3 take away negative 4 is 7. 8 minus 8 is 0. Now we have a 0 on the bottom. This is what shows us that this slope is undefined. And if you look on this graphing calculator, if I wanted to actually try that calculation, 7 divided by 0, it tells me right now there's an error, something's wrong. You can't divide by 0. So if you see a 0 on the bottom, that means that we have that undefined slope or a completely vertical line. So those are ways that we could identify rates of change. We can see the 4 types of slopes that we need to identify, which are positive, negative, a 0, and an undefined. And we could start to use this equation, y1 minus y2 over x1 minus x2, to find the slope between 2 points that we tell you on a graph.